Okay, my name is Kristian Nudlash. I am a sophomore at UAA, and I'm from Dillingham. I got to spend my summer in Dillingham here working with my mentor, Chandler Kemp. And so my project was focusing on energy usage in mariculture. And for this project, when I talk about mariculture, I'm mostly focusing on kelp and oyster farms. And one of the interesting points that we discovered after doing our research was that going faster in a boat does not always mean you're going to have worse fuel economy. So the main goal of the project was to work towards improving energy efficiency. But in order to improve energy efficiency, you have to first understand what energy or how energy is being used within the mariculture field. So we decided to do research on how energy was being used in transit to mariculture sites, during harvesting and processing. And one of the other important goals that we were working towards was just making connections with local mariculture leaders around the state, just to be able to understand what they think would help make things easier for them and improve energy efficiency. So my project fits into the mariculture industry by laying the groundwork for a best practices guide for energy efficiency. The mariculture industry is projected to expand into a $100 million industry within the next decade, thanks to the help of a $49 million grant. And this project is attempting to help lay groundwork in order to guide future grant spending. So to start this project off, I thought it would be a good idea to review similar research, which consisted of peer-reviewed papers that have been published. And there wasn't a whole lot. And most of the things that I found somewhat relevant mostly pertained to finfish farming, and that wasn't really what we were interested in. So I then decided that we had to do some primary research ourselves. So I designed a system to log fuel flow data from outboards. There's a picture here on the left. At the top here, we just have a 12-volt battery to supply power to the system. We have the cable here that plugs into the outboard, and that provides the system with RPM data, fuel flow data, and then a few other things we didn't need, such as oil temperature. Down here at the bottom is the backbone of the system. So the power and all of the devices hook up to this, and it transmits data. Up top here, we have the GPS, a display to view all the data in real time. And then all the way on the left here was the data logger to record every single piece of information that was being transmitted. And we use this system in Sitka, Larsen Bay, and Kodiak, where we conducted sea trials with partners, with our the project partners. And this consisted of hooking the system up to the outboard and going with the tide, increasing our RPMs at set intervals, and then turning around and going against the tide, doing the same thing in hopes to kind of cancel out the current. And then, so with all of that data being recorded, I then had to write a program to interpret the hexadecimal logs that the data logger recorded in order to make it human readable and more easy to manipulate. And that program eventually was able to create graphs that we then shared with our project partners. And here's a picture of two of those graphs. So on the left here, we have a boat that we did 3 different sea trials on at different weights. On the y-axis here, we have the fuel consumption in gallons per hour. And on the x-axis, we have the speed over ground in knots. And this graph here kind of just highlights how much weight, how much load can affect the fuel economy versus speed. So on the orange here, we have over 2,000 pounds loaded into the boat. And it wasn't able to go very fast, but it burned just as much fuel as the boat unloaded going 20 knots. And then on the right here, we have a graph that kind of highlights that first point I talked about at the beginning of the slideshow. On the y-axis, instead of the fuel in gallons per hour, we have the fuel economy in nautical miles per gallon. And this graph highlights the importance of being able to get the skiff on step and kind of making the bow pick up. It creates less drag and just makes the boat go a lot faster. The biggest challenges during my project was, as I discussed, there was kind of a lack of previous research I was able to reference. And I wanted to make the fuel flow monitoring system non-invasive. The team I'm working with, the system they were using previously involved clipping into fuel lines, which I didn't really want to get into. And I think the biggest issue was working with the data. It was kind of a pain having to just process it so much and having to convert it several times. And the advice I would leave for whoever picks up where I'm leaving this work off at is to be prepared to manipulate databases with Python using Pandas, and they should acquire more engine interface cables for all the major manufacturers. The one that I bought for the kit that we were using was specific to Yamaha, so it didn't work with any other brand of outboard. And that's just how they make the cables. My biggest successes with this internship was designing this fuel flow system and then writing the program to process the data that the system recorded. I am excited to see how this research is expanded upon and where the mariculture industry is headed. The thing I enjoyed least was reading the papers. It was just kind of a slog to get through some of them. And my favorite thing about my research was that I know I have created things that'll have a lasting impact even after I leave. I think the system is going to continue to be used for quite some time, and the program that I wrote is going to be able to be expanded upon in the future. All right, do we have any questions?
Yeah, thank you so much, Kristian. Great job. Okay, do we have any questions in the room for Kristian? Yes, okay. Bringing it back.
So what other things use energy in the mariculture systems besides the boat that you might want to monitor in the future?
One of the things that we discussed with one of our partners was the processing side of things. So in Kodiak, they're currently freezing or blanching and freezing the kelp. They weren't really drying it. And that, I think kelp is about 90% water. I'm not 100% sure on that, but so a lot of the processing and shipping, I think on the shipping side, that could be brought down a lot. And then the way they harvest, they use little diesel power generators to power equipment. And I think those could be electrified.
Awesome. Thank you. Did we have another question? Yes.
So you mentioned that traveling around and working with the partners and stuff was a pretty essential part of your summer. What was your experience like working with them? Were they excited to have this data, or were they kind of nervous to have you kind of involved?
I think they were all pretty excited. I think most of them were pretty curious to see what was best, the best way to drive to improve the fuel efficiency, and just to see kind of how much fuel they were burning throughout the process of going to and from the site.
Awesome. And then got one more in the back.
I was wondering if potentially down the line with mariculture, they would be considering potentially switching over to electrically driven boats, just kind of like a general electrical vehicle conversion.
Yeah, I think that's kind of the whole idea of the green energy portion of this grant, is that they are hoping to electrify as much of the process as they can within reason. And I think electric outboards are one of those possibilities.
Awesome. Thank you so much. Let's give another round of applause.
All right, thank you.